Okay, in this class I want to talk very quickly about Newton's laws, connected particles, and introducing the idea of friction in here as well. So I've got a 4 kilogram particle connected to another particle by a taut, light, inelastic string which passes over a smooth, light pulley at the edge of a rough horizontal table. The coefficient of friction between the 4 kilogram mass and the table is mu. The system is released from rest, and both masses move 1.5 meters in their first second of motion. Both particles move 1.5 meters in their first second of motion. What I want to do is I want to find ultimately the value for this thing mu. Okay, what is the coefficient of friction? It's given us lots of information in here. A couple of things to note. It tells us, how far these things have moved in 1 second. We do know there'll be a constant acceleration because the force is constant. So we're going to figure out a few basic things. One thing I'd always start with is by drawing a couple of force diagrams. And think about force diagrams for these particles. We have the 6 kilogram particle. We have the 4 kilogram particle. We're going to come up with some information based on this. We might come up with some equations, and then we'll come back and think about how we can find mu. So the 6 kilogram particle, there's a mass, there's the force on that particle by gravity called the weight, which is always mass times little g. There's the force on that particle by the string pulling upwards, which is called a tension force. In the 4 kilogram particle, it has its weight acting down, the force on the particle by gravity, which is always its mass times little g. In this case, there will be a normal reaction, a force on this 4 kilogram particle by the table acting upwards. And there's also a force to the left here on the particle by the string. That's called the tension force. And there is friction between the table and the particle acting backwards, friction. And the maximum friction is going to be used. I know that because the system started moving. So the system tried all its tricks to stop it moving. The friction tried to stop it moving by using its maximum amount of friction, but it wasn't able to do. So the friction is always mu times r. You got to remember that. The maximum possible friction is mu times r. Looking over here at this first particle, it should be plain enough at this stage to say that the normal reaction is 4g. There will be no upwards or downwards acceleration for the 4 kilogram mass, so the normal reaction has to equal to the downward force 4g, which means friction is just going to be mu, whatever mu is, 4 mu times g. That's going to be my friction force. Okay, I'm going to look at my force equations based on Newton's second law, F net equals ma. We know that. Before I, do my equations, I'm going to think about the 6 kilogram particle. It's fairly obviously going to be moving downwards. The 4 kilogram particle, it's fairly obvious it's going to be moving to the left. So those are the directions I'm going to choose to be positive. If I'm taking my first equation from the 6 kilogram particle, it's going to say downward force 6g. The net force will be the downward force combined with the upward force, which is negative here, minus t. And that's going to equal to mass times acceleration 6a. Okay, looking at my second force diagram, we're looking at the left and right forces. Positive to the left, so t is positive, 4 mu g to the right, so we're going to get t minus 4 mu g, that's my net force, is equal to ma, and we can, figure out some stuff from this. So the t's here will cancel on addition. I'm going to get 6g minus 4 mu g is equal to 10 times a. Okay, so I can find the acceleration by dividing on both sides of that by 10. So the acceleration is going to be 6g minus 4 mu times g all over 10, which would simplify to 3g minus 2 times mu g over 5. That's the acceleration. However, it's in terms of mu. I don't know what mu is at this stage. So I can't find the acceleration just yet. So there has to be another way. And the other way is just to think about this. We know that acceleration is constant. G is constant, mu is constant, g is constant. It's a constant acceleration. So we know we can use the master equations. We're told the system is released from rest and moves 1.5 meters. So s equals 1.5 meters in the first second. So if we think about this system, what do we know about it? Well, we know the acceleration is constant because the force, the tension force, is constant. And it tells us the system is released from rest and both masses move 1.5 meters in their first second of motion. It's released from rest, so u is equal to 0. And we're also given that displacement is 1.5 when t is equal to 0. So we know s equals ut plus a half at squared. We have that equation. S equals ut. Notice u is 0, so ut is be 0. So s is just going to be a half times a times t squared. Solving that equation for a, doubling both sides, 2s, dividing both sides by t squared. T squared is going to be a. We know s, we know t. I must have an error in here. T is not 0. S is equal to 1.5. That doesn't make any sense. When t is 1, of course, when t is 0, s is 0. I've taken that down incorrectly. So when t is 1 there, s is equal to 1.5. When t is 1, so we get the acceleration has to be equal to 2 times 1.5 all over 1 squared. That's equal to 3 meters per second squared. So that's the acceleration of the particle. I want to find mu. I think I said that was the thing I was interested in to start. Well, we know the acceleration can be written in terms of mu. So I'm just going to set this value equal to acceleration. So therefore, let me just squeeze it in over here. So we know the acceleration is 3. Therefore 3, and we know that can be written in terms of mu as 3g minus 2 mu g over 5. Multiplying on both sides by 5. 15 is equal to 3g minus 2 mu g. I'm going to add 2 mu g to both sides. I'm going to subtract 15 from both sides. And now I'm going to just divide on both sides by 2g. So mu is going to be 3g minus 15 over 2g. That's a constant. Meters per second squared. That's the coefficient of friction. Okay? If you want, you can plug it into your calculator and see what you get. It was an ordinary level question, so in the Leaving Cert, the ordinary level students take g to be 10. So for ordinary level students, they would say mu would be 3 times 30 minus 15, which would be 15 over 20, which equals 3/4 of, I shouldn't say meters per second squared. That's an error. Mu is equal to 3/4. There's no units for the coefficient of friction. It's just 3/4. Okay? So, apologies. Errors there and there. But, no harm seeing that errors are, things that can happen. Okay? So, no units for friction. Mu is 3/4. T is equal to 1, not 0. That's given in the question. Okay? Just address your errors if they crop up. There's no big deal. Okay? So practice, practice, practice.